So, hello everyone, I am Sujal and today I am here to present my ISE activity for our course Unmanned Aerial Vehicle with electronics and sensors, and our course conductor is Mr. Sabrivan sir. And moving towards our project, which is speed detection using UAV technology. So now we will go towards our project. This is our project in which now I will introduce to our project. The project is called car speed detection using YOLOv8 and OpenCV. It is a computer vision program. Takes a video as input and detects moving vehicles such as cars, buses and trucks, and then it can estimate the speed of each vehicle and shows it on the video in the real time. So technologies used here are Python programming, OpenCV, YOLOv8 and Mat library. Moving towards the working of the program, first of all it loads the YOLOv8 model, then open the video file, then it goes to record video frame and frame by frame. It detects vehicle using YOLOv8, then finally filters only vehicles, then find the center of each vehicle and calculate the speed, then display the result, then our program will quit. So the output will be shown on the video window, and it can detect each car speed with the green box. Inside the green box the car will be displayed and the speed will be displayed on the top of it, and the vehicles updating their positions and speeds frame by frames. So applications here used are it can be used in traffic monitoring system, can help estimate vehicle speed. So moving towards conclusion, the project demonstrates how AI and computer vision can be analyzed video footage to measure real world motion. So now we will move towards our program. So first of all, in this program, here some libraries are included like ultraviolet, Volo, CV2 and Mat. So next is model. Here we have used the YOLOv8 for the processing unit. Then here this part of program is used for the initialization parameters. Then next is processing video frame by frame. Here it is used. Then the Volo's execution will be executed from here. So detection will be specifically of the car will be here. Then speed calculation will continue from here and draw the result with the frame. They are concluded from here, and displaying the output of our program will be continued from here. And this is the last point, which is cleanup. Now we will execute our program. Here our program is executed. You can see one car is stopped and it is showing speed of 0 km/h. Now we will wait for some time for car come. Now you can see one car is coming, and that car is denoting with the green box frame around it. Now you can see the speed on the top of the frame. Here it is showing it is around 10 to 20 km per hour, because here is one corner from where the car is turned and it is taking speed upward. Now here another car is coming. Now it is came in the frame and indicating the speed of the vehicle around 20 km per hour. Wait a minute, our third vehicle is coming. Here it is came. Now this vehicle is also detected in our program and it is indicated in frame and its speed is around 40 km per hour. Here our fourth vehicle has came. Also another 61 is came. Their speed is around 20 km per hour. One more vehicle has came. And its speed is also around 20 km per hour. We have used here kilometer per hour unit, so basically it is used in Indian unit, which is kilometer per hour. Now here we will see the another video as an input. So here you can see a large amount of cars are here and it is detecting their speed. Here also bikes are also detecting. All cars and bikes are came in frame. Now we will see another input video, and this is the another input for our program. So here it is executed. Now you can see cars are at around 40 to 50 km per hour and they are gradually increasing because there is a slope over the road. Their speed is increasing over time. So when cars comes in our frame of our camera, it will detect it and create a frame on the cars and display the speed over the frame in kilometer per hour. So that's all about our project. Thank you.